Thank you for coming to my talk. I'm excited to be here with you. My company is building my company is building a system that allows developers to respond to Security Hub findings autonomously. The system itself is simple, but I'm particularly focused on the concept and operation of the system, with a strong emphasis on ensuring that developers can use it without difficulty. My name is Akira Nishikawa. I am a security engineer at a Japanese company called Kaminashi. Kaminashi is a SaaS company, and I basically look after the security of their products. And I am also an AWS community builder. First, I'd like to share where we are aiming to go. Let me share some background information. At Kaminashi, we provide multiple SaaS products. As shown in the diagram, it has each service has its own AWS accounts for development and staging and production environment. We have enabled Security Hub we have enabled Security Hub in each of these AWS environments, and the findings are consolidated and managed in an audit account. Securing the environment of a service is the responsibility of the engineering is assigned that service. Our role as a security engineering is to enable this engineering team. In that system, I'm introducing today for addressing is part of that enablement effort. Security Hub findings is part of that enablement effort. Our mission in security engineering is to not secure the product itself, but to share the security, the principles, practices, and knowledge with engineers. In other words, we support them from the outside rather than directly securing the product. This reasoning behind this approach is that if we were to take on the responsibility of directly securing the product, it might take away the developer's sense of ownership over security. In that case, that areas we can oversee may become secure. But vulnerabilities could still be introduced in other places where the service context extends. Which may not fall within other place are our visibility or controls. We also place a greater importance detective controls rather than preventive controls. This is because ultimately the ownership of the AWS environment lies with the developers. The most important mission in security engineering is to build a security culture. This means maintaining a constant awareness of security. Our goal is for engineers to keep awareness of security. At the forefront, dividing design, development, and operation. Next, since our company is a startup, we tend to prioritize speed. Of course, speed is important, but we strive to maintain agility while implementing minimum level of security without compromising it. On the other hand, we don't aim to we don't aim to strengthen security to the extent that it significantly reduces agility. Finally, security issues are sometimes overlooked or deprioritized, but our goal is for engineers themselves to recognize these issues and take action rather than relying on security engineering to point them out. I'd like to talk about the level system we developed to achieve these objectives. In Japan, we eat various types of meat, including liver. Eating liver doesn't taste good to everyone. However, it is very healthy for you. We named the system liver. It is similar, and many people try to avoid performing this kind of security. It is very good for you, even though it is very good for you. The structure is as simple as this. The findings detected from each account are aggregated to the audit account, and then sent to the aggregate the audit account, sent to the security tooling account via event bridge, and processed by Lambda function in the security tooling account. We don't implement this in the audit account. It's that we want to keep keep the account created in AWS Control Tower as clean as possible to prevent drift. Level allows you to set a minimum severity for each AWS account to be notified. For example, if critical is set, only critical notifications will be sent to the on-call person. And if high is set, high and critical notifications will be sent to the on-call person. There are three main concepts of level. I will explain them in detail. Notifications are meaningless if you don't know what to do. We are notifying you so that you can take action in order to prevent the same problem from occurring in the future. The explanation ticket we also provide. Ticket focuses on why the action must be taken. We also provide a set of how information so that developers can take action on their own. Explain why it is essential to address this issue to prevent it from happening again in the future. By communicating the how along with the information, we aim to create an environment where developers can take action on their own. We don't want to include anything that doesn't need to be addressed. For example, if we accept the risk, we will clearly state the reason in the ticket. If we are notified of something that we don't have to respond to, you might end up being like the boy who cried wolf. As far as responsibility is concerned, if you rely on the team, you lose ownership or end up relying on people because the same person always responds. For this reason, the unique feature of Kaminashi's on-call person on-call system is that notifications are made to individuals. This approach helps ensure these risks don't fall through the cracks. Even if the primary person doesn't receive the call, there is a secondary person, so that there is a backup system in place. The role of the on-call person is to be responsible until the ticket assigned is closed. The on-call engineer doesn't necessarily handle the tasks directly. but may work with the team members to close the ticket. Regarding guard duty detections, the security engineer will also work with you to investigate. It's quietly that the developers may not be able to respond to certain notifications due to a lack of specialized knowledge. For instance, guard duty can detect attack like domain generation algorithm. Even if a developer sees such a detection, they may not immediately understand what it means. Our policy is collaborate because understanding such attacks requires specific knowledge with methods involved. Next is risk management. We have created the matrix address risk. We usually multiply the consequence and likelihood to determine of risk. But for Security Hub notifications, we use the severity listed in the findings at the risk value. The reason is that the engineers at Kaminashi do not yet have enough knowledge to estimate the likelihood and severity of the Security Hub findings. In principle, high and critical are supported, but not if there is a reason to do so. For example, the severity of notifications can be service handles important information or not. If you include high from the beginning, a large amount of paging will occur. In such a case, this method is also effective, and it is possible to only handle critical at the beginning. Also, Security Hub detects even resources created by AWS Control Tower, but if you respond to them in the opposite way, drifts will occur. Control Tower or AWS-Control Tower in the resources ID in the Security Hub automations. In this way, the use of automations is indispensable for proper operation of Security Hub. Security Hub configuration has also been very helpful. Before we start full-scale development, we create a prototype AWS account that we assume will be discarded after development is completed. We don't do any Security Hub detections here. However, we want guard duty to detect it. So we apply a policy to the OU that disables all controls to control it. Automations and configuration are two of my favorite Security Hub features and are essential to the operation. Last part, I will share the operational design and outcomes. We spent a lot of time thinking about the operation design. This took more time and thought than implementation, and there was a lot of discussion within security engineering team. Especially with AWS accounts for all the services, there are a lot of Security Hub findings. And no one knows why these resources are configured the way they are. Since Kaminashi is a startup, business speed must also be a priority. We spent a lot of time trying to find out how labor accept the developers. As I mentioned earlier, we set up the automation in the Security Hub to exclude those that didn't need to be handled to some extent in Kaminashi. Then when labor paged the on-call person, that would change the ticket in the ticketing system to in progress. This change acts to the on-call system side. If not, the reason for not responding will start it in the ticket, and the CTO will make the decision. If the CTO says no, the engineering team must respond. If they decide that they don't need to take action, they manually set the findings in the Security Hub to suppressed. When the response is complete, the ticket is marked as down. If there is no problem with the response, AWS config will not detect it again. But if the response is incomplete, the ticket will be created again. Since Kaminashi is still a small organization, the CTO makes the decision now. But in the future, PPOE and others will take on this role. If you take the Security Hub findings seriously and respond to them as they are, you may have an accident. We actually had a minor failure when we started production. An empty S3 bucket had been set to public and was detected as a critical alert. But the engineers decided that since it was empty, deleting the bucket would not cause any problems, and delete it. However, the bucket was configured to redirect. When you introduce a mechanism to an existing AWS account, this kind of accident can happen if you don't fully understand the context of that environment. And it can happen even if you do fully understand it. So shift left is important, and I think it's best to introduce a mechanism like lever as early as possible and take action before it's released to production. For a service that has been around for a long time, there are a fair number of high and critical findings, and it's difficult to operate with this system from the beginning. Therefore, we set up a 1 month ramp-up period, during which we ask the engineer team to tag resources that they ignore. The purpose of having the engineering team tag resources that are not needed in the context of the service, or because it would be very costly to check with the CTO each time they are ignored by the lever automatically. We have changed the operation so that when a new tag is added to a resource that was created with a ramp-up period, the resource group's tagging API is used to detect it so that we can check why the tag was added. Also, in the case of auto-scaling resources, they will be detected and paged each time they are auto-scaled. However, in the case of auto-scaling resources, the resource may already be gone after some time. Therefore, there was no better way to exclude such resources than to tag them. The slide shows an example of a production environment for one service where lever was deployed. In the first week of operation, 17 critical findings were reduced to 0, a notable achievement considering the many resources with unknown configurations or backgrounds in the environment. However, high, medium, and low risk findings still remain. We will continue to improve our systems and operations to create a more secure and robust environment. Thank you for listening.